All right, so now we're heading into factoring quadratics. And to start off, we're going to look at factoring a trinomial. Now remember that a trinomial is going to be an expression or possibly an equation that has three terms where the largest term has a variable that is squared. Then you have a second term where the variable has a power of 1. And then the third term is just going to be a constant. In between those terms, we find either positive or negative signs. Those positive or negative signs are going to tell us a lot about how we're going to factor them. So let's start by looking at x squared plus bx plus c. What we know is that when we look at that positive that's in front of c, that positive is going to tell us that both of our factors are going to have the same sign in them. So it's either going to be a plus and a plus or a minus and a minus. So to determine whether we've got two positives or two negatives, we're then going to look at the sign that's in front of the b term or the bx term. And in this case, we've got a positive. So the positive c tells us they're the same. The positive bx tells us that they're both going to be positive. If we go over to x squared minus bx plus c and we look at that, again, the positive in front of the c tells us that they're both going to be the same sign, but the negative in front of the b tells us that they're both going to be negative. When we move over to x squared plus bx minus c, the negative in front of c tells us that the two factors are going to have different signs. So one is going to be a positive and one is going to be a negative. Now, the one that is positive and the one that is negative, we've got to figure that out by doing our factoring. But what it does mean is that whichever number is bigger is going to have the positive sign in front of it. Whichever number is smaller is going to have the negative sign in front of it. Then when we get to the final type, we've got x squared minus bx minus c. So again, that negative tells us that we're going to be looking at one positive and one negative. But since we've got a negative in front of the bx term, that now tells us that when we do our factors, the larger number in the pair of factors is going to be the negative sign, or is going to have the negative sign in front of it, and the smaller number in that pair of factors is going to have the positive sign in front of it. We're now going to take what we just learned and put it into practice. So the question for problem number 1a is, what is the factored form of x squared plus 9x plus 20? So again, we're going to start out by looking at what is the sign in front of the constant, and it just happens to be positive. This tells us that we're going to have the same signs for both sets of parentheses. Then we look at the sign in front of the bx term, which is again positive. So that tells us that we're going to have positive in both the first set of parentheses and a positive in the second set of parentheses. The next step is to then look at what are the factor pairs for the number 20, or what are the factor pairs of the constant. So when we break down our factors for 20, we get 1 and 20, 2 and 10, and 4 and 5. Now, because we have the same signs inside of both sets of parentheses, we're going to add them. We're going to add those two factors. And whichever pair of factors adds to the b term, which is 9, is going to be the set of factors that we're going to use for our quadratic factoring. So when we do 1 plus 20, we get 21. When we do 2 plus 10, we get 12. And when we do 4 plus 5, we get 9. So the 4 and the 5 are the ones that match that bx term, so that's what we're going to use when we plug in to our quadratic factors. So what this means is that our factors are going to be x plus 4 times x plus 5. Now the way that you would check this is to go ahead and FOIL this out. X times x is x squared, x times 5 is 5x, 4 times x is 4x, so 5x plus 4x is 9x, and then 4 times 5 is 20. We would get x squared plus 9x plus 20, so that means that our factors do multiply out to our original quadratic trinomial, which means that we do have the correct solution. We're going to go through the same process in problem number 1b. This time we've got what is the factored form of x squared plus 14x minus 72. So again, check the sign in front of the 72 or in front of the constant. And it's a negative, which tells us that we're going to have one positive and one negative. Then the sign in front of the 14 tells us that of the factor pairs, the larger number within that factor pair is going to be the positive, and the smaller number within that factor pair is going to be the negative. So now we need the factor pairs of 72. So the factor pairs for 72 are 1 times 72, 2 times 36, 3 times 24, 4 times 18, 6 times 12, and 8 times 9. You may want to go ahead and memorize that factor pair list because you're going to see 72 quite a bit. Now what we're going to do with this, in the first problem we added the factor pairs. But because we've got opposite signs now within our parentheses, we're actually going to subtract these. So we're going to go 72 minus 1 is 71, which does not equal 14. 36 minus 2 is 34. Again, doesn't equal 14, so we're going to continue on. 24 minus 3 gives us 21. 18 minus 4 gives us 14. Well, that's going to be the one we're going to use. Just to finish this out, we've got 12 and 6 is going to give us 6, and then 9 and 8 is going to give us 1, just to make sure. So we're going to use the pair 18 and 4, and 18 is going to go in behind the positive, 4 is going to go behind the negative, so we get the factors x plus 18 times x minus 4. Again, to check and see if your work is correct, you would go ahead and FOIL this all through, and it would give you x squared plus 14x minus 72. Okay, we're going to switch this up a little bit now. We're going to have what is the factored form of negative x squared plus 13x minus 12. So in this case, our a value is a negative. So to deal with this, what we want to do, go ahead and rewrite the equation, but then factor out a negative from all the terms. So we pull out a negative 1, and we're left with x squared minus 13x plus 12. Now again, keep that negative on the outside of your factor, but we're going to factor what's inside of those parentheses now. So start off again looking at your constant, and now it's a positive rather than a negative. So that tells us that both of our signs are going to be the same. We look at the sign in front of b, and it's a negative, so we know that both signs are going to be negatives. We do have that negative hanging out still in front of the first set of parentheses. But go ahead and do your factor pairs, and the factor pairs for 12 are 1 and 12, 2 and 6, and 3 and 4. Since we've got the same signs in front or inside of the parentheses, we're going to go ahead and add these together. So 12 and 1 gives us 13, and that is going to be the one we're going to use because 6 and 2 is 8, and 4 and 3 is 7. So we choose to use 12 and 1. Now we're going to go ahead and put, it doesn't matter where we put the 12 and the 1, because we've got negative signs in both of our sets of parentheses. So you can go ahead and do negative times the quantity x minus 12 times x minus 1, and those will be your factors. If you were to go ahead and distribute that negative back through to the x minus 12 and then FOIL out your results, you would end up with negative x squared plus 13x minus 12. In problem number 2a, we're going to be doing a fairly simple sort of factoring, and this is factoring out the GCF, or the greatest common factor. So we're given what is the factored form of 6n squared plus 9n. So when we look at this, we're going to take a look at anything that looks alike first. So we've got our two coefficients here. We've got a 6 and we've got a 9. So we ask ourselves, what goes into both a 6 and a 9, and that's 3. So we're then going to look at the n squared and the n, and we're going to say, how many n's do I have in n squared? Well, there's 2. How many n's do I have with just an n? And there's 1. So what is the smallest number of n's that are common to both terms, and that's 1. So you take out 1n. So we're taking out a 3 and an n. When we say we're taking out a 3 and an n, what that means is we're going to divide 6n squared by 3n. Then we're going to divide 9n by 3n. The result is going to be our factor. So we've got 3n goes into 6n squared 2n times. Then 3n goes into 9n 3 times. So we're left with the solution 3n times the quantity 2n plus 3. In problem 2b, we're looking at what is the factored form of 4x squared plus 20x minus 56. Now, one of the rules for factoring is that you should always look for a GCF first. So we're going to take a look at 4x squared and then 20x and then 56. We only have a variable on the first term and the second term, so we can't pull out any x's. But if we look at 4, 20, and 56, the greatest common factor between those three terms is going to be 4. So we can take 4 out of each one of those. So when we do that, we're going to pull the 4 outside of the parentheses, and we're left with x squared plus 5x minus 14. At this point, we do our normal factoring, which is going to be looking at that second sign. It's a negative, so that means both. We're going to have two different signs inside of our parentheses. Then we look at the sign in front of the bx term, which is positive, so that tells us that the larger number in the factor pairs is going to be positive. And then we do our factor pairs. So for 14, it's 1 and 14 and 2 and 7. So because we've got opposite signs in our parentheses, we're going to subtract these. So 14 minus 1 gives us 13, and 7 and 2 gives us 5. We know that we're looking for that 5, so our factor pairs are 7 and 2, so that gives us x plus 7 times x minus 2. Those are our factors. Now you notice that I dropped the 4 off. The reason why I dropped the 4 off is because it's actually not needed at this point. If we had pulled a 4 with an x out of the original equation, then we would keep that, but we don't need just the number. The only reason why we would want to have that 4 is when we go back and check and make sure that we've got our original equation, then we would distribute that 4 through so that we could get all the way back up to 4x squared plus 20x minus 56. Okay, in problem number 3a, things are going to get a little bit more complicated. So what we can see is that a has been replaced by a 2. So we're no longer dealing with an a value of 1 or negative 1. So we're going to have to do a couple more steps on this to be able to figure this out. So go ahead and write down your original quadratic trinomial and check your signs, and you can see that we get positives in both. What we're now going to do is we're going to take the factors of a. So the factors of 2 are 1 and 2. Then we're going to look at the factors of 12, which are 1 and 12, 2 and 6, and 3 and 4. What we have to do is we have to multiply each of the values of a against each of the values of c. And then because we've got the same sign in both factors, we're going to add those together. So we're going to start with 1 times 1 gives us 1, and 2 times 12 gives us 24. Add those two numbers together, you get 25. We're looking for a b value of 11, so we know that one doesn't work, so we're going to move on to the next step. That step is going to be now multiply the 1 against the 12 and multiply the 2 against the 1. When we do that, 1 times 12 gives us 12, 2 times 1 gives us 2. So 12 plus 2 is 14. It's still not the 11 that we're looking for. So we know that 1 and 12 are not part of the solution here. We're going to then move on to 1 and 2 and 2 and 6. Now with 1 and 2 and 2 and 6, I'm going to go 1 times 2 and 2 times 6. So 1 times 2 is 2, 2 times 6 is 12. Add those together, you get 14. Still not what we're looking for. So now go 1 times 6 and 2 times 2. 1 times 6 is 6, 2 times 2 is 10. Or 2 times 2 is 4, 6 and 4 gives us 10. Still not the 11 that we're looking for. So that means that 2 and 6 cannot be part of the answer. Now we're going to move on to the final set of factors, which is 3 and 4. So we're going to go 1 times 3 and 2 times 4. 1 times 3 is 3, 2 times 4 is 8. Add those together, you get 11. The 11 is going to be our solution. The other, if we had done 1 times 4 and then 2 times 3, those together would have added to 10. So again, that would not have been our solution. But we do have our factors, which again are going to be 1 and 2 paired with 3 and 4. So we're going to go the 1x is going to go first. Now, since 1 times 3 is the combination that works, if we put our 1x on the outside, that means that 3 also has to go on the outside. Then that means that 2 is going to be paired with x on the inside, so 2x in our first slot on the inside, and then 4 in the slot on the inside opposite the 2x. So we get x plus 4 times 2x plus 3. To see if we're correct, we again FOIL. So x times 2x is 2x squared, x times 3 is 3x, 4 times 2x is 8x, so 8x plus 3x is 11x, and then 4 times 3 is 12. So we do get the original equation of 2x squared plus 11x plus 12. Okay, we're going to take a look at 3b now. What is the factored form of 4x squared minus 4x minus 3? Again, we're going to check for GCF, which there is none, then look at our signs, and our signs indicate to us that we're going to have opposite signs inside of our parentheses, and that the larger of the two factors is going to be negative. So we now need to look at the factors of a, and a is 4, so we get 1 and 4 and 2 and 2. Then we do the factors of 3, which is 1 and 3. And so we're then going to start multiplying our factors together to see if we can get a difference of negative 4. So 1 times 1 is 1, 4 times 3 is 12. Subtract those and you get 11. 1 times 3 is 3, 4 times 1 is 4. You subtract those and you get 1. So we're going to move on to 2 and 2 for our a value. So 2 times 1 is 2, 2 times 3 is 6, 6 minus 2 is 4, and that is the value that we're looking for right there. So we know that we've got the pairs of 2 and 1 and 2 and 3. So we're going to put our 2x's in the first positions in each of the parentheses, and then we're going to pair them up with a positive 1 and a negative 3. And again, if you check this by foiling, you're going to end up with 4x squared minus 4x minus 3. All right, we're now going to take a look at a type of quadratic trinomial called a perfect square trinomial. And they're always of the form x squared plus or minus 2xy plus y squared. So we can have either a positive or a negative in front of our b value. Now the positive or negative in front of the b value then determines, are you going to have a positive or a negative in your factor? So a factor is always going to be of the form x plus or minus y squared. If you have a positive in front of the b value, then you're going to have a positive in your factor. If you have a negative in front of your b value, then you're going to have a negative in your factor. Now there are some specifics that you need to know for perfect square trinomials. These are going to help you to identify them. First off, perfect square trinomials, because they are trinomials, they have to have 3 terms. Then ax squared and c have to be perfect squares. You can have a number, or you can have a coefficient out in front of that x squared, but it would have to be like a 4 or a 9 or a 16, something that's going to be a perfect square. Then your c value, or in this case what we are referring to as y squared, also has to be a perfect square. So it would have to be 1, 4, 9, 16, 25, and on and on and on. Then for a quadratic trinomial to be a perfect square trinomial, in standard form, b has to equal 2 times the square root of ac. So that means we're going to take the a value and the c value, multiply them together, then take the square root of that and multiply it by 2, and that's going to be the b value. You're going to see how this works in just a little bit when we actually start doing some of these. And then the sign, like I said a little bit earlier, is always going to be the same as the sign in front of the bx term. Now let's see how this works. So we are asked, what is the factored form of 4x squared minus 24x plus 36? So we would factor out the GCF, and we are left with 4 times x squared minus 6x plus 9. And we're going to look at, does b equal 2 times the square root of ac? When we look at the x squared term, we now have a 1 as our a value, and our c value is 9. So 1 times 9 is 9. The square root of 9 is 3. Multiply that by 2, and you get 6. So does 6 equal 6? Yes, it does. Then we're going to look at what is the square root of the c value. The square root of the c value is 3. So what we're going to do is we're going to take the square root of the a value, or the ax squared, which is just going to be x. That becomes the variable in our factor. Then we take the sign that's sitting in front of the b, and that's negative, so we're going to pull that down. And then we take our square root of c, which is 3, and that becomes the second term in the factor. So we get x minus 3 squared is our solution. Our second type of special factoring is called difference of squares. And in this one, you're going to see it in the form of x squared minus y squared. It's always going to look like this. So what that breaks down to is x plus y times x minus y. In order to be difference of squares, it must be 2 terms. And it must be a subtraction problem, and ax squared and c must be perfect squares. So any variables that we have, any coefficients that we have in front of our variables have to be perfect squares, and the variables have to be perfect squares as well. So again, we're going to practice difference of squares. What is the factored form of 25x squared minus 49? So again, write it out and look for any GCF that you might have. We don't have any GCF here, so we're going to skip straight to are ax squared and c perfect squares? The answer is yes, because the square root of 25 is 5, the square root of x squared is x, and the square root of 49 is 7. Is it a subtraction problem? Yes, because you have a negative in front of the 49. So then we just take what is the square root of ax squared, which was 5x, what is the square root of 49, which is 7, and then we put those into our factors as 5x plus 7 and 5x minus 7, and you're done.